Last class we discussed about inline constraint. Inline constraint means I want to write some constraints in my module. Okay, then I will go with my inline constraint. I want to override some constraints. Okay, so then go with the inline constraint. And then soft constraint. Soft constraint means you want to you are writing some two or more constraints. Okay, so in that some conflict will be getting like value greater one constraint you are saying that value greater than 50. In other constraint you are saying that value less than 50. At that time the conflict may occur. So to avoid that conflict, you will use this soft keyword. Wherever you don't want constraint at that place, we are applying that soft keyword. Okay, and then randomization methods. We have seen that randomization methods like randomize, pre-randomize, and post-randomize. Pre-randomize and post-randomize are the fallbacks of the randomization. Okay, so what is the use of that pre-randomize and post-randomize? Before randomizing, you want to print something, then go for the pre-randomize. Okay, so after randomization, you want to print the values, then go for the post-randomize. Okay, you are not writing any display statement in your module, just post-random function void post-randomize method you are using in your class. Okay, it will print the values. Okay, that is the purpose of randomization method. Now today we will discuss about rand case. So just tell me what is the difference between the case and rand case? What is the normal case operation? Okay, we can write the multiple statements while selecting single value. We can based on the single value, we can select multiple values, right? But it is in the order, right? So like 4 by 1 multiplexer you are taking there. So two select lines are there. Then S0 and S1 based on that 0 0 or 0 1 1 0 1 1 case. You are selecting some values like Y0 equal to I0 you are selecting, Y1 equal to I1 you are selecting, Y2 equal to I2 you are selecting. Okay, that is the normal case statement. So rand case means we are giving some probability of occurrence. Okay. So based on the weight, we are selecting multiple values. Based on the weight, it is getting the chance of getting the value whoever having the highest weight. Okay. Whoever having the highest weight. So those are the chance to get the values multiplication times. Okay. So that is the case we are using this case rand case statement. Like normal case statement, what is the selection? So 0 you are selecting means only one value task A you are getting. Okay, for one task B you are getting. So equal probability. So whatever you are selecting, based on the selection, you are getting the output. But compared to the rand case, see, rand case 1, 3. In this, which task is getting more compared to that? So weight is 3 is having task B is having highest weight. Then the more chance to get that output is task B. Okay. So compared to task A. Hmm. Here what we are saying that some probability of occurrence values. See, normal case statement. So think of it as a normal case statement plus the weighted probability. Weighted probability means we are giving some values, weights. Okay, like how we are selecting that case statement. Basically, we are writing like this case some selection. Okay, in that selection 0 0 0 1 1 0 1 1. So based on this, we are selecting some values y naught equal to getting the output y I naught, and then y1 is equals to I1, and y2 is equals to I2. Okay, y3 equal to I3. So in this way we are selecting that case statement. Okay, but rand case, what is the use of rand case is, so some giving probability of occurrence. Okay, based on the selection here, I'm giving the weights like 2, 5, or 7, 9. Okay, what is the total weight here? 16, 21, 23. Okay, so based on the 23, this is the total weight, and then in that, what is the highest weight we are having? In which case we are having, suppose some display A you are writing. Okay, same display B we are writing. Okay, and then display C I am writing, and then display D. Okay, who is getting the chance, more chance? So display D is the more getting chance is there because weight is high for this one. Okay, so that is the use of rand case. Rand case is depends upon the random selection as well as some rand case. That means weighted probability. Weighted probability is there, and then random selection and normal case statement. All these three combinations giving as a rand case. Okay, so this is the normal case, and depending upon the select line, we are getting the some output. Similarly, rand case also having some weights here. 1, 3. So 3 is the highest weight. Then task B is more appears compared to task A. Okay. So that is the rand case. See, imagine so putting a colored balls in a bag. Okay, so you know Bayes theorem, how to get that values. One red ball is there, three blue balls are there, six green balls are there. Then probability of chance is total 10 balls are there. Okay, the probability of chance of red ball is coming is 1 by 10, and blue balls 3 by 10, and then green ball 6 by 10. Then who is getting more chance here? Green ball compared to the red and blue, right? Okay, same way. So you blindly pick one ball. This is exactly how rand case works. Okay, so based on the weights, you are picking randomly based on that who is having more weights, and here who are having more values, more colored balls, they are getting more chance, right? Appearing at the output side, they have the more chance to appear at the output side. Okay, same way here 1, 3, 6. Then display high, display medium, display low is there. Three statements are there, and 6 is the having highest probability. So then I will get this 6 is the output side. Okay. So simplest random case. Here equal probability. So 50-50. That means the weight is having 1 and 1. Okay, that means both are getting the chance equal probability 50% and 50%. Then I don't know, I'm not telling you that display 1 is getting more and compared to the display 2. No, display 2 is getting more compared to display 1. So we can't say that. Suppose the probability is 80-20 means, so then from display 2 is getting more chance compared to the display 1. That is the weighted selection. See, 1, 3, 6. Which one is having highest probability here? 6. This is the 60%, 30%, 10%. Then 60% is more getting chance. Okay. So to get the output. Okay. Same way. Repeated random selections. So repeated random selection means so you are repeating 10 times. Then in these 10 times, I'm having the total weight is 10. Okay. So then display C is getting more compared to that display B, and then uh, display 1. Okay. So we are getting either display C is the first one. In that display C is getting more chance. Okay, repetition of getting more chances there because the weight is 10. Out of 10, you are repeating also 10 times. Then display C is getting more chance to get at the output side. Okay, we are getting the output is weight 7. Okay, C can appear most often times. See, 1, 2, 3, 4, 5, 6, 7. 7 times we got it at the output side. So that is the repeated random selection. And then through tasks, we are giving some task is having highest priority. So high priority and low priority tasks. That means it's like some processes. Okay, I'm giving some processes like low priority task and high priority task. Who is having the highest priority here? Wait, high priority is the more weight compared to the low priority. Then the maximum possibility of chance is here 80 per, so total 6 is there, right? So weight is 6. So then 5 by 6 means approximately 8 8 6 48. Okay, 8 times 2 times and then 30. So 83% chance is there. Okay, and here remaining percent is 17%, 1 by 6. Hmm. So based on that priority, we are getting output at the display side. So this we are getting the display at the output side based on the weight we are giving. Similarly, packet generation 70, 20, 10. What is the chance? Normal packet is the highest chance compared to this error packet or corner packet. Okay. You understood, right? So what I am getting the output side. So that is the rand case. So normal case compared to that rand case, we are giving that some weight. Based on the weight, we are getting the output. Which one is having the highest weight? That will be appeared at the output side. Okay. Same thing. Rand case inside the class. So inside the class also I'm using some rand case. Okay. So we are using some rand case with inside some this class. So class is a packet. Inside that function void choose mode. Okay. Method I am applying that. Previously we are applying some tasks. Okay. Task and method both are same, right? Okay. Task and function. So both are methods. Then I am applying methods in my class. That method I am calling it the output side. Dynamic weights. Difference between the rand case and distributional. You know, distribution is also working like same thing rand case type. But we are having some distributional constraints in our classes. What is the use of distributional constraint? I want to repeat some person particular number of times. Okay, those many times it will be repeated. That is the purpose we are using distribution constraint. Same way here also rand case, right? Rand case is also repeating based on the weight, how much weight you have given. Based on the weight, it is getting the output. See this summary. So when the wheel spins, every selection has a chance to be get a chance to be selected. Okay, but larger selections are more likely to win. Same way, rand case is also works exactly like a prize wheel. Okay, in prize wheel, one number is repeating more number of times, then there is a chance to get that number only at the output side, right? Suppose 2 is repeating. 2 is repeating 9 times. So in that 15 numbers are there. 2 is 2 only randomly repeating 9 times. And then 1 is repeating 3 times. 0 is repeating 2 times. And 3 is repeating 1 time. Then who is getting more chance? 2, right? Same way here also works exactly the same case regarding random case. Next, interprocess communication, IPC. What is the use of that? IPC means what? Interprocess communication. What is the use of that? We have different type of things related to interprocess communication like events and then semaphores. Semaphores are used for synchronization purpose and events also synchronization purpose. Mailbox is used to communicate between the two components. So in our test bench, driver, generator, all these things are there. To communicate between these two components, we need a communicator. Then mailbox we are using. Okay, all these three processes like events mainly used for synchronization purpose. Okay, and then semaphores shared resources like four people are there are working on the same interface, then the simulator will get confused to whom to give you the permission. Okay. At that time, semaphore will come into the play, and then based on the key concepts, it will give you the access. Okay. And then mailbox. Mailbox is a like a see here. Event is a doorbell. He's saying that event is a doorbell, and then semaphore is like a room key. Okay, and then mailbox is a courier box. Courier box is used to send them information, right? Courier companies are there. Whatever the parcel I'm placed in that courier company, their duty is to send my parcel to one of your home. Okay, so I'm sending some gift to you. Okay, so then through parcel I'm sharing that. Okay, so then parcel courier person don't know about that what type of parcel I'm sending. Okay, just they need to know the send address and then to address. That's it. See, uh, what is the use of inter-process communication? One of the biggest challenge in verification. Uh, how do multiple parallel processes and communicate with each other? That is the problem. Parallel process communicators. Okay, parallel processes are there. How they are communicating parallelly. Okay, at a time they want to communicate it. For that purpose, we are using this IPC, inter-process communication. Okay, so driver consumes the transactions and monitor captures the transactions. Scoreboard checks the transaction. Okay, so remember in your entire test bench, the communication is happens between the DUT and test bench is one is driver is communicating to DUT, and DUT is communicating to test bench like this. Okay, this is my driver. Okay, this is my driver, and here there is a DUT, and this the driver is transmitting the signals to the DUT through interface. There is an interface is there, virtual interface and normal interface is there, and then the driver is communication in two-way directions because sometimes DUT will give you the signals and sometimes driver will give you the signals to the DUT. Okay, and then there is a monitor. So this monitor is communicating to the DUT. Driver is giving the inputs stimulus to the DUT and DUT producing some outputs and monitor captures them. Okay, so this monitor is giving to the scoreboard. Okay, scoreboard is comparing that. So expected values and actual values. Actual values anyway the DUT will give you. Okay, monitor will capture them. And then scoreboard will compare that actual values. These are coming from the actual values. All these are actual values. And here some input monitor is there. This input monitor is also connecting to the scoreboard. Here reference values, that is expected values, are coming here. Okay, these expected values and actual values both are equal means then your scoreboard is passing then your test case is completed. Okay. So that is the reason here saying that driver consumes the transaction, monitor captures the transaction, scoreboard checks that. See, what is the use of inter-process communication here? Suppose I'm having different tasks, task A, task B, and then task C. All are different initial blocks. Like I'm in task A, okay. So then that is in one initial block. He is a task B, he is in another initial block, and she is a task C, another initial block. All the initial building blocks are working at the same time, right? At zero simulation timer. Then how I know the task B is completed and how I know task C is completed and how you will know task A is completed, right? We don't know. So that is the reason we are using these events. Okay, so both run independently. So here three tasks are you are considered, and then all three tasks are running independently. Okay. So same way, I need to select that. So this IPC will solve this problem. We need to select different processes. Okay. So based on this event, the event is used for synchronizing purpose. Most of the times, synchronizing purpose. Both are in sync with that. Okay. Synchronization means suppose I am talking, right? I am writing something. I need to synchronize with that both the action as well as voice. Okay, if I'm writing something on a board, okay, bell equal to event. So I'm talking about the bell and then pointing this bell. I'm talking about this event. I'm representing this event. Okay, so then here we are talking each other and then doing the action at the same time. Then both are synchronized, right? You are watching a movie. Okay, the voice is coming earlier. After that, the action will be going on. Then is that watchable? No, right? Because the synchronization is missing. Because voice is coming frame compared to that video. So both are in sync with that. Then we need to inform that. So both are not synchronized with the clock. So we need to synchronize both the voice and then video. Then only we can watch clearly. So same thing here also talking about this events. Events are used for synchronization purpose. Okay. So most of the cases we are using for synchronization purpose. I am declaring the event. Event name is done. Sometimes event I am representing E1 or event E. Okay. Anything. Event declaration. Okay. This is declaring the event. Okay. Here, these events are happening four ways. Triggering the event, waiting for the event. The waiting is two types at the rate event done. Okay, at the rate is related to waiting for the event. Okay, we are waiting for the event, and then this hyphen greater than implication operator. So what it is called as implication operator. This implication operator is used for main purpose is like triggering the event. Okay, so triggering point. Triggering means that is the basic event occurring, right? So I want to trigger my event. So that means wake up call, right? So triggering is nothing but waking up. And then before triggering, we need to be stay in event wait condition. So triggering condition, wait condition. Sometimes I will also write this wait condition like event one dot trigger. Okay, so wait condition also there. And then sometimes we will use this non-blocking events. Triggering point, this is non-blocking. Non-blocking and blocking, what is the difference here is, this is also triggering only, but compared to the blocking, non-blocking, we are giving some schedule, like Rapido, we are booking the cabs during night time, but we are scheduling that cab is, I want a cab at 4 o'clock because my flight at 6 o'clock. Okay, so then I need to reach the airport within the time only. So for that purpose, I am scheduling the cab. Okay, so same thing. Event is never missing, right? So because if I forgot to wake up, then cab person will call me, and then I will wake up. Okay, so that is the non-blocking triggering event. Okay, this is the non-blocking triggering event. So here, triggering event, non-blocking triggering event, at the rate condition, and then wait condition. Okay, four operators are there in the events. So first, basic event example. What it is doing here? Module TB, event done, initial begin, #10, dollar display triggering the event. So this display is displaying at 10 seconds delay. Okay. Here I am triggering the event. This is my triggering point. Okay. And then initial begin dollar display waiting. Okay. At the rate done. So see, one thing you need to observe here, triggering the event after 10 seconds delay is there. Before that, I am waiting here. This is waiting condition. When you are waiting at t equal to 0 time only. Okay, t equal to 0 time only you are waiting for someone to trigger the event, right? So simple thing. Uh, I want to catch my cab at 7:30. Okay, then I'm started at my route at 7:30 only. Then will I reach that cab? Because the cab is at 7:30, then you are started at your room at 7:30, both are at same time, then obviously you are not reaching the cab, you are not reaching the event, right? Same way, your cab is 7:30, then you started at your room at 7:20, then you reached at that point 7:25, so 5 minutes before. To reach the cab, you are there at 5 minutes before. Then you are catching the cab, right? Because you waited before event trigger. Okay. So before the triggering the event, we will be waiting there. Stop, right? Same way here also, you need to be there in your room before someone rang the bell. Okay. So before ringing the calling bell, you need to be stay in your room only. Then only you will be capturing the, you will be catch the event. Otherwise, you never catch the event. Okay. So the event is used for synchronization purpose. Before triggering that, you need to be stay in wait condition. Okay. The wait as at t equal to 0 at time, and then triggering will be happening at some other time. The delay is 100 seconds. No issue because I am waiting there only. I will never miss my event. Okay, so that is the synchronization. See now here, what is the output we are getting expecting here? I am having module TB event done initial begin. So #10 the triggering event is happening. Okay, here at t equal to 0, I am waiting. So this waiting is the output at display side. After that, uh, I need to get this output, right? Event received. But why I'm getting the triggering event first? Because this person is waiting, someone needs to trigger that person. Otherwise, that event is never happened. Okay. 10 minutes before the event is triggered, and then I am waiting before 10 minutes. Okay. Before 10 minutes onwards, I am waiting here, then event is received. Okay. This is the way you will be getting at the output side. They will ask you, how do you implement the events? Okay. Multiple waiters, like here I am using this start one. Okay. So now tell me which one is the chance to get the output here. Multiple waiters are there. Okay, starting an event. The event will be starting here. Event start. That is the start. E is the hyphen name of the event, and then I'm utilizing the function. Huh. So this is the name of the event start E, and then initial begin at 10. The event is triggered. This is triggering. At 0th time, t equal to 0th time, start is there. Okay, and then process 1 is started. Same time, process 2 is also started. Okay, both are at starting and t equal to 0th time only, right? Then what is the output you are getting? I am getting the output is process 2 started first and process 1 started next. This is one possibility, right? And some other case, process 1 started and process 2 started. This is another case. Both are having the same chance, right? Because the simulator will not know which one is getting first. Okay. So because the initial begins, two initial begins are starting at t equal to 0 only. Okay. These two are starting at t equal to 0. Then I may get process 2 is first or process 1 next. Or process 1 first and then get process 2 may next. Okay. This is the chance of getting the output. Okay. Next, difference between the event and waited event. Okay. At the rate event and wait event dot trigger. Okay. What is this difference? Both are same. But here at the rate condition means we are waiting at the edge sensitive. Okay. So either positive edge or negative edge, we are taking that. Positive edge or negative edge. Okay. So positive edge clock or negative edge clock. We are waiting at this edge sensitive. So works only if waiting starts before triggering occurs. Right? Before triggering occurs only, we need to wait that. Then only we never miss the event. Otherwise, there is a chance to miss the event. Okay. Same way here also, I am having the event E. Okay, initial begin, and then this is the triggering point. After that, some one wait condition at the rate E is there. Will detect the event. Is that detecting the event? No, right? Because the event happened at t equal to 0 only. Triggering is happened at t equal to 0 only. This is triggering. Triggering is happened at t equal to 0. But event, I'm starting waiting after the event triggered. Then I'm never detect my event. Then there is a chance to, not a chance, missing the event. Okay. Now, this event is occurred at what is the hash delay? Some 10 seconds delay. Is that getting the output here? Okay, never miss the event, right? Because the triggering is happened at 10 seconds delay. Okay, so the triggering is happening at hash 10. After that event is triggered. Okay, the event will be triggered. I'm waiting 1 second before. Okay, so after 1 second, I'm started waiting. Then still I am waiting at 9 seconds. Then the event is triggered. Then I will detect the dollar display event at the rate e event. At the rate event I am using that. Then I am waiting before that triggering. Then I will detect my event. Okay, dollar display. You can detect the event. Same thing. So module TB is there here. Event transmit done. Task is the transmitter and packet sending. The event at 20 seconds delay. Okay, that is the triggering event. And here task receiver at the rate transmit done. Then you are waiting at what time? The event is waiting at t equal to 0 only. Okay, then the event is triggered at 20 seconds delay. 20 nanoseconds delay, the event is triggered. Got it, right? Okay. So then event is triggering or not? Both are doing at the same time. I'm using the fork join. Then transmitter and receiver will be working parallelly. Based on the delays, it will be getting at the output. Okay. So output side, a transmitter will be appeared and then receiver will be appeared based on that delays mentioned. Okay. Same way, non-blocking events. Just take some minutes. You understood, right? Here we can execute some basic codes related to events. Basic event. What is happening here? Module TB event done. Okay, so here I am commenting this hash 10. Okay, dollar display triggering the event. This is the triggering point. And then dollar display waiting. And here at the rate done, dollar display event is received. Is that receiving the event? Because the two initial begin blocks are working at the same time. Okay, so you are reaching the stop, and then at the same time only the cab is here. Both are at same time. I don't know the event is received or not because the both the events are triggering at the same time. Okay, see here we received that event is triggered and then waiting that event is received. Okay, the event received is not getting because both are starting happening at the same time, but the event is triggered. Still, I'm not receiving the event received because both are at the same time means so we need to run to catch the clock, right? So that will not happen in the system. Guys. So manually you are doing that running, but the system is not running, right? Hmm. Then I am applying some delay. Now, is that event received? It will receive obviously because you are waiting before 10 minutes only. The event is triggering before triggering. You are waiting. See, the event is received. Okay. So waiting at 0 time and triggered at 10 seconds delay, and then event is received. Okay. This is the basic event condition. Okay. Similarly, another module TB event done. The driver is sending transactions. This will be happened at 10 seconds delay. The event is triggered at 0th simulation time or some other delay. Okay, and then initial begin 0th simulation time monitor is waiting. Okay, at the rate done, the monitor transaction is receiving. Now tell me what is the output display you are getting here. So event triggered, this one, and this one is also waiting is also at 0 simulation time, right? Waiting and triggering both are happening at the same time, but sending transaction is taking some time and transaction is received at 0 simulation time only. Okay, so just check that what is the output you are receiving. The event will be captured, not missing the condition, right? Because you are waiting at 0 simulation time only. See, 0 simulation time monitor is waiting. Okay, sending the transaction at 10 seconds delay, and then event is also triggered after 10 seconds delay. Okay, because the event triggering is happening after 10 seconds delay, right? And then waiting at 0 simulation time. But why the receiving is at 10 here? Because I'm waiting before 10 minutes. The event is transaction is receiving happen at 0 simulation time only, but it depends upon the waiting the event. Who is triggering? Okay, it depends upon the triggering time. I am triggering the event after 10 seconds delay. That is the reason the transaction is receiving also taking 10 seconds delay. Understood, right? So actually I am waiting at 0 simulation time only. But the event should be happened after 10 seconds delay. Before you are waiting 10 minutes, that waiting period is also you need to add that. Understood, right? Suppose I am giving the delay here, the event will be happened 10 seconds delay only I am giving. What it will happens here? Waiting at 0 simulation time. No, I think transaction is not receiving here because you are happening the triggering the event at the same time and then receiving the event also same time. Now here I'm giving here 100 seconds delay. Is that happening the event? Right? It will happen, right? Because I'm waiting at 10 seconds delay, the event occurs at 100 seconds delay. Okay, so then at 100 time, the monitor captures the transaction received. Understood? What how it will happen? Otherwise, if you add the delay here more, then what it will happen? Event is not received. I'm, wait- I'm waiting at 1000 seconds delay. Okay, someone is ringing your bell, you are not there at home, and then after 1 hour you are reaching the home. Is that person is waiting at 1 hour at the outside? No, right? He will wait. So the event never happens here. Okay. So because at 1000 seconds is the event is not happening. Okay. Understood, right? So here it will be happening because I'm waiting at 10 seconds delay. and then event triggered at 100 seconds delay, then I am waiting before triggering only. Then my event is received. Clear? How we are getting the output here? Same multiple waiters. Like I'm having multiple waiters PB event happening at triggering at 10 seconds delay, and then starting the event, and then process 2 is also started at the same time. Now I need to check that which one is happening first, because both the persons want to access the system at the same time. Okay, who will win the race? Yes. Process 2 started first. After that, process 1 started. So waiting at 0th simulation time, both are waiting at 0th simulation time only. Okay, you want to display the time, you can display it percentile 0t dollar time you can write there. Okay, understood, right? Multiple events. Same thing here also, multiple events are there, but I'm giving some delay here. Module TB, event start E, and then hash 10. The driver is triggering the event, and then so hash 10 I'm commented here, hash 5 only I have considered here, and then process 1 started at the 0 simulation time only, process 2 started. What will happen here? Who will occur the who is getting the output here? 0 simulation time waiting 2 is waited. After 5 seconds delay, okay, waiting 1 is happening. Okay, first waiting 2 and then waiting 1. Then here 10 seconds delay is there, the event is triggered. Okay, who is triggering first here? Process 2 is started, because at 0 simulation time only process 2 is started, and then 5 seconds delay process 1 is started. Okay, understood, right? How it will happening the event. Suppose I am giving the delay here 20. Is that event 1 happens or not? No, right? Because event 1 is still waiting after the event triggered. Okay, so waiting is happening, but driver is triggering the event at 10 seconds delay, and then event 1 is waiting at after 10 seconds. So that means 10 seconds is ahead. Okay, then process 1 only started here. Process 1 started and process 2 started. So process 1 is started. Why process 1 is started here? Okay, okay. See, process 2 started, waiting at the event, and then event is triggered at 10 seconds. Process 2 is done at 10 seconds, and then waiting 1. So we are doing the waiting 1, and then process 1 is not yet started. So because the event delay you need to decrease here. Okay, here hash 2 I am giving, then process 1 also receiving the event. See, so here I am giving the delay 2, but still I am getting delay 10, because the waiting delay. Who is triggering? How much delay is taking here triggering? 100 you are giving means you will be getting 100. See, 100. Okay. So waiting two, waiting one, process two started, process one started. Clear? Similarly, non-blocking events. Non-blocking events means we are giving some delay. That means scheduling the events. After that, we are receiving the event. Okay. Then event never missed here. Event will be happening. Non-blocking event. What is the event difference here? This is the blocking event. This is the blocking event. This is the non-blocking. So single implication operator is blocking, and double arrow is there. That is non-blocking event. Okay, why exist? But very few understand that why it exists, when it is used, when to use it, and how it works inside the simulator. Okay, so see here, two events are happening. Rings the bell, waiting for the bell. Okay, waiting at 0 simulation time, and ringing will be happened at 10 seconds delay. Okay, then you are waking up, and then the event will be receiving. You are not missing the event. So everything works here, but if what if bell rings, person B started waiting, then the event is happened already. Okay, the bell already happened. Person B misses it forever. Okay, so that is exactly the event is blocking event. Okay, so the event is happened previously, and then you started waiting after the event happened. Then there is no use of it, right? Same way, non-blocking event. So here we are scheduling the event. So I'm schedules the event for NBA region of the current timestamp. That means here bell rings here, and then bell rings at the current timestamp. That means some tiny delay is there to prevent the race condition. Okay, so like a blinking time. Okay, if you blink your eyes, so that much delay is there, and then the event will never be missed. Okay, so your event is not missing. So this tiny delay prevents the race condition. Then basic event declaration and blocking case, whatever the event is happening, both are events are happening means the event is not received. The event will be triggered, but receiving is not happening because both are happening at the same delay time. Okay, so that will not be happens in the real time. Okay. So here non-blocking events. Non-blocking events means here I am waiting at the same time. So will I receive the event here? Definitely will receive them because here the waiting will be there. That means you are ringing the bell at the outside, and then and you are waiting for me because you need to meet definitely. Definitely you want to meet me. Then you are waiting at the output side of it. Then the event will be happening. Some delay. After some delay. Here race condition will be happen, right? So here the event never caught because the event is triggered at t equal to 0, and then waiting also t equal to 0 at time only. Then event never happens. You will not receive the triggering point. Okay. Same code, but here the event will be happening because the event will be happening after scheduling. Then we have given some delay internally because the event will be happened at blocking region. Okay, you are waiting at blocking region. The event will be happening at non-blocking region. That means the simulator will wait. Okay, up to receiving the event. Here also, is that happening the event? You are triggering the event after delay. You are waiting at time t equal to 0 only. Then the event will be happen. Okay, because you are waiting 10 minutes before only. Same way here also, multiple waiters. Generator to driver and then event with mailbox. See, I'm putting some transaction in my mailbox. Okay, some put and get methods I'm utilizing. Put method, you are inserting some data. Get method, you are getting the data here. Okay, so MBX is the mailbox handling. Mailbox dot put transaction, you are keeping the data here. And here I'm ready to consume the data and getting the data. Okay, that means receiving the data. You are waiting at t equal to 0 time only. Okay, so this is non-blocking event. Then NBA region it is going that this will be happening at active region and this will be happening at non-blocking region. Okay, so in timestamp we are waiting, right? So this will be active and this is inactive and this is NBA region and this is postponed region. Okay, the NBA region will be happened after the active event. Okay, just check this summary. Same thing, non-blocking events will check here. Huh. See, this is the non-blocking event. Module TB event E. So event is triggering after 20 seconds delay. Okay, and then waiting at 0 simulation time only. Okay, then event will be happened here, right? Hmm. See, waiting and then triggering happened. After that, receiving. Shall we do both are at same time? 0 simulation time only. I'm doing here. Is that my event received? Yeah, received. Same, same thing. Here, first is waiting. After that, triggering is happening. Okay. Instead of non-blocking, if you are using blocking means same event, same code, just waiting will be triggering at waiting and triggering are happening both the time. Then here we are missing the event. Okay, so that is the difference between the non-blocking and blocking. Here blocking we are missing the event and non-blocking, so we have some delay in your output time. Okay, waiting will be happening 0 simulation time and then triggering will be happen after some delay. See here triggered and waiting and then receive the event. Okay, that is the non-blocking beauty. Okay, so here because the non-blocking will be happening after the active region. Okay, that is the reason it is waiting that to receive the event. Same thing, 10 seconds delay I am giving here. Okay, module TB, initial begin hash 10, and then you are waiting at 0 simulation time only. Then event will be happened, right? The triggering is happening at 10 seconds delay and waiting at 0 simulation time only. So at 0 time only I am waiting here, and after 10-second delay the event is triggered, and then I will be receiving the event here. Clear? So how to avoid the race condition? We know. So how to we to avoid the race condition means non-blocking events. You need to consider that. So both are happening at the same time, and then here based on the non-blocking event, the event will be received. Okay, the event will caught it here, and then triggering and caught the event. Okay. So instead of this non-blocking, if you use blocking means the event will not be caught. Okay, we are missing the event. So I am utilizing fork join here. The fork join will be happening at the same time. Producer and consumer both are happening. The task producer and task consumer is there. So both are happening at 0 simulation time only. The event is triggered at 0 simulation time, and then waiting will be happened after 10 seconds delay. Then fork join none you are taking or none join any you are applying. So both will be happened at the same time or different time, you can check that. See, completed and then started. That means the event is triggered here. So here not completed, you can write started here. Okay, started here and completed here. Okay, then producer and consumer both join none here. None not applying the none here, and both join and taking. Okay, both join, then completed at 0 simulation time. See, started at 10 seconds delay and then completed at 10 seconds delay. Okay. So because you are waiting at this condition 0 simulation time and then started at 10 seconds delay. Clear? Okay, Priya, are you getting me?